Hey everyone, what's going on? Welcome to Focus here. So here in this video, we will see how we can tune the hyperparameter for logistic regression. So in the previous video, we have seen that how we can incorporate regularization term. And for that, we got one hyperparameter that is the lambda. Okay, so we have to tune that perfectly for which we can best fit our logistic regression model. So how we can actually do the hyperparameter tuning. It's almost similar to what we have done in k-nearest neighbor. Okay, so let's just revise what was the optimization function. So that is our W star, that is the optimal weight vector. What we have to do, we have to minimize this whole term. The first term is contains loss function and the second term contains regularization function. Right. So here I have shown you the L2 regularization. Anyway, you can use elastic net, you can use L2, you can use L1, whatever it is. But here I have shown you the L2 regularization. And here this is lambda, which is the main focus of this tutorial. So that is hyperparameter tuning. So like KNN, again we have to choose different values of lambda. Now if you remember in KNN, we we have chosen value of k as integer values, right? It cannot be a real number. That means a floating point number. It cannot be. K value cannot be a floating point. It should be always an integer number. Okay. But here in this case, lambda could be a real number as well. Okay. So say you have chosen a wide range of lambda, say 100 lambda values, starting from say 10 to the power minus 5, 10 to the power minus 4, 10 to the power minus 3, till 10 to the power 7. Some value, I mean, it should not be in this way. Like here you can see a pattern. This is 10 times of that. This is again 10 times of that. This is typically done by the people, but it should not be like that. Okay, you can choose any value. You can choose a broad range of value. You can choose a small range of value, whatever it is. So I mean that is kind of a POC that you have to do. But anyway, you have to choose a good range of lambda values. Okay. Then what you have to do? You have to train the logistic regression model for different values of lambda. For this value of lambda, again for this value of lambda, again for this value of lambda. For this whole value of lambda, you have to train your logistic regression model and you have to log the validation error. You have to log it, right? Specifically, the cross validation error. Because once you get the cross validation error, it will be something like this, not exactly like this, but it will be something like this. And the best value of lambda should be the one which is actually creating the lowest cross validation loss, right? So that's a similar thing that we have done in KNN as well. So this is how we can get the optimal value of lambda. Now there are two things or two techniques you have to learn by which you can do this. What should I say? That hyperparameter tuning. So the first one is grid search. Now this is nothing like the name is kind of fancy, but this is nothing. It's similar to what I have explained just now. You have to take a value, you have to take a range of values for lambda, and for each of the lambdas, you have to train your logistic regression model and you have to log the validation error. Then you plot that validation error versus lambda graph and get the best lambda out of that graph. Okay, so that is as simple as that. That is called a grid search. Okay, so basically you are picking the points from a grid of points and training your model. Okay, now there is a drawback for grid search. So I have shown you that while using the elastic net regularizer, you have two hyperparameters, lambda 1 and lambda 2. So basically the number of hyperparameters are more than one. Now you have to get or you have to tune your hyperparameters, this lambda 1 and lambda 2, so that you have to get the best value, the best combination of lambda 1 and lambda 2, for which we are getting the lowest cross validation error. Okay. So now for that, for both lambda 1 and lambda 2, you have to specify a range of values, right? For lambda 1, you have specified 100 values. For lambda 2, you have specified 100 values. Now, if you think logically, what will be the total number of combination between lambda 1 and lambda 2? That is length of lambda 1 and length of lambda 2. So that is if both the lambda 1 and lambda 2 is a 100 dimensional list or having 100 separate lambda values for each of the lambda 1 and lambda 2, then the total number of combinations will be 100 into 100, right? So that many times your logistic regression model should run, right? For this combination first, then for this combination, then for this combination, right? So this is how total 100 by 100 combinations of logistic regression should run. Now that is pathetic, right? Because I mean, you don't have much time, you don't have that much resource, you have to deliver your model very quickly, something like that. Some constraints will be there always. So that is one drawback, you can say, for grid search. But anyway, like, grid search is a widely used hyperparameter search, and its literature is very very, very well written, and it's proper actually for hyperparameter tuning. But it is sometimes also called the brute force search, because you are not using any smart technique to get the proper value of hyperparameters. Now, if you want to get some more somewhat smart techniques for hyperparameter search, you can go for random search. From the name itself, I guess you understand, it is randomly searching the hyperparameter, the best hyperparameter. Now, how does it work? Considering these examples, you have two hyperparameters, lambda 1 and lambda 2. Okay, so how many combinations will be available? 100 by 100 combinations will be available. Okay. Now, random search, what it will do, it won't go sequentially. It won't check all the values like grid search. Okay. It will only take random values, random combination values of L1 and L2. Say out of 100 by 100, it is taking, say 1000 values, and training your logistic regression model 1000 times. Then you will plot the validation, you will log the validation error, then you will plot the validation error, and you will get the combination of lambda 1 and lambda 2. Okay. So now, if you might think that how random search is I mean, how are you sure that random search is getting the perfect combination of lambda 1 and lambda 2? Yes, that's true. But it has proven in the literature that random search is almost uh, as correct as grid search. Now you can try by yourself. It's as correct as grid search, because even grid search also cannot give you the perfect combination or perfect value of hyperparameter, because it will search for the hyperparameter uh, you are you have instantiate. Because say if I have given this particular value of lambda, and maybe the perfect lambda value is 0.345, and that is not present in this list. So even grid search also cannot give you that particular value, but it's okay. Grid search or random search will give you the nearest value to that, and that's perfectly fine for us. So when you have multiple hyperparameters, and when you have a huge amount of data or a heavy model that takes time to train, that time it's always better to use random search, because it is time efficient than grid search, and also it is almost as correct as grid search. So these are the two techniques which we will see in action when we will go through the code walkthrough for logistic regression. So now grid search is a brute force method, and random search is kind of smart technique. There is another smart way to find hyperparameter, that is Bayesian hyperparameter search. That is fairly an advanced concept, but anyway, like, in future I will try to cover that as well, because nowadays Bayesian search or Bayesian hyperparameter search is like a hot cake. So anyway, but most of the time we use either grid search or random search, and that gives us a promising result. Okay. So what we have learned in this video, we have learned that what is our hyperparameter, that is lambda, and how we can get the perfect lambda value to best fit our logistic regression model, either using grid search or using random search. Okay. So this is the end of the video. I hope you have enjoyed. If you like the video, do subscribe to my channel for future videos and share with your friends. Till now, have a nice day and happy machine learning. Thanks much for watching.